At some point, the camera in the last video decided to zoom in. I didn't do it. The camera did it all by itself. Sometimes it zooms back to a point maybe 7 miles away, and everything becomes really tiny. And I have no control over that. I just try to keep my eye on the screen, but sometimes I miss it. So that can happen. In any case, I don't know if that happened in the preceding video or while I was constructing the graphs that we're going to use in this video. But let's just recapitulate. We started with our basic 4x4 square for the y equals x squared function. We picked a random point over here, and then we moved this square so that the red dot moves from here to here. And we got the graph of a new function. We estimated the coordinates of this point to be 8, 3.3, so that this graph has been shifted 8 units this way, 3.3 units this way, 8 units horizontally, horizontals that way. I didn't know that. I really didn't have a good handle on horizontal and vertical when I went over to college either. It's a lot of really good courses and really good teachers and stuff, but somehow that would escape me. But anyhow, 8 units horizontally, 3.3 units vertically. Okay. So we say that the function y equals x squared. Of course, this is our toolkit function. Also, notice I didn't do a real good sketch of this. This is a little better, but it's not perfect either. In any case, this y equals x squared, we call it y equals f of x. So we say that y equals f of x equals x squared is transformed to a y equals g of x function. And you saw this was on the screen. That function is x minus 8 squared plus 3.3. We put, instead of x being squared, we square the x minus 8. And the 8 comes from the 8 units that we shifted horizontally, the 3.3 from the 3.3 units we shifted vertically. Then we kind of verified that the point 10.7.3, which is on this graph, and it's real easy to see why that is. 2 units over this way, and then 4 units up from the y 3.3 line, we get 10.7.3. We plug 10 in for x, and we do the arithmetic, and we get y equals 7.3, verifying that 10.7.3 is on the graph of our g of x function. Okay, so there we have it. Not sure everything, especially low and to the left here, because of the zooming, was visible. Okay, now what we're going to do is we're going to do this same thing with the exponential function. So again, we've got our what I call fundamental square. It's a dot here at the origin. And we've got -2 here, we got 2 here, we got y equals 4 here on this line and all that stuff. And without putting any function in here at all, I just move the square over here so the dot goes to 8, 3.3. And I'm going to say that if this function is y equals f of x is shifted to get y equals g of x over here, which equals f of x minus 8 plus 3.3. Now, one good use of function notation. Again, if you're fuzzy on function notation, well, give a little thought. I'll be careful to kind of explain what I'm doing with it. But this function notation allows me to name whatever function goes in this square. That'll be the f of x. And whatever goes in this square is going to be g of x. And what goes in this square is related to what goes in this square, because the way I shifted this graph. And I get a little nervous because I think I just heard the camera do something. but no, it looks like it's okay. Okay, sorry. G of x then is f of x minus 8 plus 3.3 because of the horizontal and vertical shifts. It's true if I've got the fundamental basic toolkit squaring function in here and toolkit squaring function in here. If I got the toolkit exponential function, which I'm going to have in a minute, in here, with the toolkit exponential function in here, be the same. This is the rule. Now, whether you totally understand function notation, well, illustrate it by what we're doing. Okay. Whatever function is in here, this function is, if this function is f of x, this function is f of x minus 8 plus 3.3 every time. Okay, so now if we do the basic toolkit exponential function, the graph is going to look pretty much like this. Not great. That curve a little too fast right there. Okay. And you see where I've marked off some lines. This is like my y equals 2 line. This is my y equals 1 line. And then we got 1/2 and 1/4. You should know how to construct that by now, or review how to construct it. It's simple enough. Got to go through here, got to go through here, got to go through here, and I got to go through here and here. So the graph something like this. So if it's drawn correctly both times, this will be the graph of the toolkit exponential function, shifted 8 units horizontally and 3 units vertically. So if this function is y equals f of x equals 2 to the x, this function is going to be y equals g of x oh man, I flew with the 8. I'm debating about how to write the 8 with this piece of chalk that's sticking. Right, this. Okay. No, I say it's f of x minus 8 plus 3.3. I said exactly the same thing when it was the basic squaring function, toolkit squaring function, f of x minus 8 plus 3.3. If the function is f of x equals 2 to the x, then when I write f of x minus 8, that means I replaced x by x minus 8. So I replace this x by x minus 8. If I replace the x in this expression by x minus 8, I get u raised to the x minus 8. And then plus 3.3. There it is. Now, let's verify this for a couple of points. Okay. This point should be as it was before, 10. And it's 7.3, not 3.3. So point 10, 7.3 should be on this function. Okay, so write it this way: if y equals 2 to the x minus 8 plus 3.3, what is y when x equals 10? Well, it had better be 7.3. And that should be totally clear to you. And if not, you want to give it some serious thought. Okay. So what is y when x equals 10? Well, I think you can read it. And replace x by 10. Well, you can figure it out, work it out. What do you get? Well, 10 minus 8 is 2. It's 7.3. So 0.8, 7.3. Better be on the graph of g of x. And it is. I'll put a check mark there. At least verify this for this point. Now you can plug any other point in, and you really should do it so you get a feeling for why when we shift plus 8 units, we have to replace x by x minus 8. Okay, it works. When we subtracted 8 from this x value, we got what we should. Okay. Yeah, think about it. Form your own intuition about why that works. Don't go with any explanation I get you. Play around with the idea. Use some numbers and convince yourself that it's really so. I just noticed one quick clarification here. What's y when x equals 10? Then I wrote if y equals 10. Well, no, that should be x equals 10. Hopefully you picked that up. I'll replace x by 10. And I just wrote the wrong letter there. Try not to do that too often, but I will do stuff like that.